question is convert 4-nitrotoluene to 2-bromobenzoic acid. Now this question and the following question is based on the chemical properties of diazonium salt. It says 4-nitrotoluene to 2-bromobenzoic acid. So first thing, you need to know the structure of both the reactant and the product. So 4-nitrotoluene is where you have a nitro group on the 4th carbon atom, and then you have CH3 on the 1st carbon atom, 4-nitrotoluene, and on the product you have 2-bromobenzoic acid. That is, benzoic acid is benzene with COOH, and then you have a bromine on the 2nd carbon atom. So this is your 2-bromobenzoic acid. So you have to think about converting this group to this one, which you obviously cannot do it directly. So what you can do is, first you can brominate it with the help of brominating agent, that is bromine water, and you are going to introduce a bromine group, CH3 NO2. When you treat it with Br2 bromine water, you will get CH3 Br on the 2nd carbon or the ortho position, and then you have NO2. Now you have to think about first removing this nitro group. Now to remove nitro group, which again cannot be done directly, so you have to think about reducing NO2 to NH2. Once you get aniline, you can convert aniline to diazonium salt by treating it with diazotization reagent. And once you get the diazonium salt, you can use the replacement of N2 group under chemical properties of diazonium salt. So in this case, we are going to replace the N2Cl by the hydrogen atom. So first let's reduce this reduction of nitro compounds with the help of H2 in the presence of nickel, and you will get Br and then CH3, and then you get aniline compound NH2. Now when you treat this with diazotization reagent, that is sodium nitrite plus HCl, you will get a diazonium salt, CH3 Br, and then you have N2 plus Cl minus. Now this group can be removed by treating it with a hypophosphorus acid or an alcohol, which acts as a reducing agent, that is under replacement of N2 by hydrogen atom. Now when you treat it with let's say ethanol, CH3 CH2OH, which acts as a reducing agent, you will get this N2 will be replaced by the hydrogen atom. So you will have CH3 Br and then hydrogen atom, which you don't have to show. Okay, now once you have got this, now you have to get a benzoic acid. So you have to think about converting this methyl group to COOH. So for that you need to carry out oxidation. So I'm going to oxidize this with the help of a strong oxidizing agent, that is KMnO4. Potassium permanganate is a strong oxidizing agent, and this CH3 will oxidize to COOH, and then you have your bromine on the 2nd carbon atom. This is the product that we are trying to get, that is 2-bromobenzoic acid. Okay, that's about converting 4-nitrotoluene to 2-bromobenzoic acid by first introducing the bromine with the help of brominating agent, and the bromine comes and sits on the 2nd carbon atom. Then you have to think about removing this nitro group, which cannot be done directly. So first you have to convert NO2 to NH2 by reducing this with the help of hydrogen in the presence of nickel. Once you have got NH2, you can convert this compound into a diazonium salt by treating it with a diazotization reagent, that is sodium nitrite plus HCl, which will produce HONO, nitrous acid, which is called as the diazotization reagent. And once you get the diazonium salt, think about the replacement of N2 by hydrogen atom, because you don't want this group. Instead, you need a hydrogen atom. So replacement of hydrogen can be done by using reducing agent. that is either hypophosphorus acid or you can use an alcohol. So in this case I have taken ethanol, which itself get oxidized to ethanoic acid, which we have already done. Now once you replace this group with hydrogen atom, now your actual product is benzoic acid, not CH3. So to convert CH3 to COOH, you have to oxidize this with the help of an oxidizing agent. So you need to use a strong oxidizing agent to convert CH3 to COOH. So in this case, I have taken KMnO4, which oxidizes CH3 to COOH, and you get your product, that is 2-bromobenzoic acid. Okay, then the next question is to convert 3-methyl-aniline to 3-nitrotoluene. Again, first write down the structure of both the reactants and the products. So in this case, you have 3-methyl-aniline, where you have a methyl group on the third carbon atom, NH2 on the first carbon atom. This is a 3-methyl-aniline. In this case, it is 3-nitrotoluene. So let's see, CH3 is this first carbon, and then you have NO2 on the first, second, and the third carbon atom. 3-nitrotoluene. Let's keep CH3 on the same carbon atom. So in order to convert NH2 to NO2, you cannot do it directly. So you have to first convert it into a diazonium salt. So you have to use a diazotization reagent for that. So when I treat this compound, that is 3-methyl-aniline, with the diazotization reagent, that is sodium nitrite plus HCl, you will get a diazonium salt, N2 plus Cl minus, and then your CH3. Now once you get the diazonium salt, now diazonium salt, under that you have started chemical reaction which involves replacement of N2 by NO2. So think about the reagent that we have to use when you want to introduce NO2 in place of N2. So for that, first we have to treat it with fluoroboric acid, HBF4, and you will get a product where you have CH3 on the third carbon atom, and here you will have N2BF4. This hydrogen and the chlorine will leave in the form of HCl. Now when you treat it with sodium nitrite, NaNO2 plus copper, and when you heat it, you will get this group will be replaced by NO2, and this BF4 will go and combine with NaBF4. So this is the product that you are trying to get from 3-methyl-aniline. So what we have done is, first we have converted NH2 to a diazonium salt by treating it with the diazotization reagent, and then to replace N2 by NO2, you have to remember the reagent, and first thing we have to use is fluoroboric acid. When you treat fluoroboric acid with diazonium salt, it leads to the formation of benzene ring CH3 and 2BF4, where hydrogen and Cl minus will leave, and then you are going to treat it with sodium nitrite plus copper, and you have to heat it, and this group will be replaced by NO2. Na and BF4 will combine together to form the byproducts. So that's about conversion based on replacement of N2 by NO2 group. The next question is to convert aniline to 1,3,5-dibromobenzene. So first you have to know the structure of the aniline and then the structure of the product that you are supposed to get, that is 1,3,5-tribromobenzene. This is your 1,3,5-tribromobenzene. Now when you compare the structure, you are supposed to introduce the bromine, then you are supposed to remove this NH2. So first I'm going to introduce bromine by treating it with the brominating agent. Now when I treat aniline with bromine water, the bromine gets introduced at all the ortho and the para position, and you will get a tri-substituted compound NH2 Br, Br, and Br. Now you have to think about removing this NH2. For that, we cannot do it directly, so you have to convert NH2 to diazonium salt. So again, I'm going to treat it with diazotization reagent, that is NaNO2 plus HCl. And this gets converted to a diazonium salt, that is N2 plus Cl minus, and you have your bromine on the ortho and the para position. Now once you have got diazonium salt, you can think about other chemical properties of diazonium salt. There is replacement of N2 by hydrogen atom. So in order to replace N2 by hydrogen, you have to use a reducing agent. So you can use either hypophosphorus acid as the reducing agent, or you can use ethanol as the reducing agent, which we have already done. Now let's take hypophosphorus acid, H3PO2, and you will get, this will be replaced by hydrogen atom, and then you have your Br, Br, Br. Now it is not necessary to show this hydrogen atom. It is understood that hydrogen atom is there. So this is your product, that is 135 tribromobenzene. So that's how we have used what we have already learned, that is replacement of N2 by hydrogen atom and converting aniline to diazonium salt. So in this case, to introduce the bromine atom, I have used bromine water. Once you get the bromine atom, you are going to convert NH2 to diazonium salt by treating it with diazotization reagent, that is NaNO2 plus HCl. And when you have got the diazonium salt, think about replacing N2 by hydrogen atom. For that, you have to use a reducing agent. In this case, I have taken hypophosphorus acid. So when you treat it with the reducing agent, this N2 is replaced by the hydrogen atom, which you don't have to show. And then you have your bromine on this 3 position. So in this case, this will be 135 tribromobenzene. That's it. And then the question number 9 is based on the chemical test that we have studied, which are used to distinguish between primary, secondary and tertiary amines. And now this question says, give a chemical test to distinguish between methanamine and N-methyl methanamine. So you can see that this is a primary amine, as 2 hydrogen atoms are still present on the nitrogen atom. In this case, this is a secondary amine because only 1 hydrogen atom is there on the nitrogen atom. This is primary amine and this is secondary amine. The first step is to identify whether it is primary, secondary or tertiary amine. Once you identify the primary, secondary or tertiary, the next step is you need to remember the chemical test that we can use to distinguish between these two. We can use carbylamine test, which is used to identify only the primary amines. The primary amines compounds will show carbylamine test, whereas secondary and tertiary will not show carbylamine reaction. And also you can use the reaction with nitrous acid, where both primary and secondary amine will react differently with the nitrous acid. Then there is reaction with aryl sulfonyl chloride. On reaction with aryl sulfonyl chloride, primary will give a different compound which is soluble in alkali solution, whereas the secondary amines will give a compound which is insoluble in alkali solution. So in this case, I'm going to use the first test, that is carbylamine test, to distinguish between these two. Carbylamine test, which is shown only by the primary amines. So when I react to this primary compound, CH3NH2, with chloroform CHCl3 plus ethanolic KOH, and you're going to hit it, you will get a product which gives a very offensive smell. So in this case, I'm getting CH3NC, that is isocyanide compounds is formed. In this case, methyl isocyanide plus KCl and H2O is released in the form of byproduct. So because of the formation of the isocyanide compounds, that is methyl isocyanide, it has a foul smell, and from the smell of the product, it is indicated that the reactant amine compounds we have taken as a primary amine. Now, if you run this secondary amine with the same reagent or the same test, secondary amine, that is CH3 twice NH, which is a secondary amine, it will not show this reaction, no reaction. So this is how you are going to distinguish between primary and secondary amine using carbylamine test. Okay, then the next one is to distinguish between these two compounds. Again, the first thing is you need to identify whether it is primary, secondary or tertiary amines. Now this nitrogen still has one hydrogen atom left, which means two of the hydrogen atoms are replaced. Therefore, this is a secondary amine. And this one is a tertiary amine because no hydrogen atoms are left, and which is substituted by the alkyl groups. Okay, so now we know that it is a secondary amine and this is a tertiary amine. You need to think about the tests which we can run on these compounds to identify which one is secondary and which one is tertiary amine. You cannot use carbylamine test because carbylamine is shown only by the primary amines. Secondary and tertiary amine both will not show carbylamine reaction. You can use reaction with nitrous acid, in which the secondary amine will form a nitrosoamine compound and tertiary amine will form a nitrite salt. And you can also use reaction with aryl sulfonyl chloride. In the case of secondary amine, it will form a compound which is insoluble in alkali solution, and the tertiary amine will not react with aryl sulfonyl chloride. So in this case, let me take a reaction with aryl sulfonyl chloride. Aryl means benzene ring, and then you have S double bond O, Cl. When it reacts with the secondary amine, that is CH3N, CH3, and the hydrogen atom. Now what happens is, this is a secondary amine. Now this nitrogen with a lone pair of electrons will come and attack this sulfur. For that, this will shift and sit in the form of negative charge on the oxygen atom, and this leads to the formation of S, O with a negative charge, double bond O, then you have your chlorine atom, and now bring this nitrogen to the sulfur, N, and then you have your hydrogen atom. I'll just write it on the top, and then CH3 and CH3. Since nitrogen has used up its lone pair of electrons in forming bond with the sulfur, N will get a positive charge. Now what happens is, this negative charge will come back to sit in the form of bond, and this chlorine will leave in the form of Cl-, and to stabilize the positive charge on the nitrogen atom, H will leave in the form of H+. Now this too will leave in the form of HCl, and the compound form will be S double bond O, N, CH3, CH3. Now the lone pair of electron is back. If you name this compound, the name of this compound is NN-dimethyl benzene sulfonamide. This is NN-dimethyl benzene sulfonamide. Now, because of absence of hydrogen in the case of secondary amine, whereas in the case of primary amine, you still have one hydrogen atom over here, because of which it is soluble in alkali solution. But in this case, you don't have hydrogen atom. It is both alkyl groups. So because of absence of hydrogen atom, it is insoluble in alkali solution. We have already learned this. Insoluble in alkali solution. So from this you come to know that your reactant is a secondary amine. Whereas in the case of tertiary amine, that is CH3 thrice N, this will show no reaction. It does not react with aryl sulfonyl chloride. That's how you're going to distinguish between secondary and tertiary amine, by using a reaction with aryl sulfonyl chloride. So this is called as Hinsberg's test, or it is also called as reaction with aryl sulfonyl chloride. Okay, now the last question that I'm going to solve is account for the following that aniline does not undergo Friedel-Crafts reaction. Friedel-Crafts reaction we have already studied. It is also there in class 11 organic chemistry. In Friedel-Crafts reaction, we use aluminum chloride as the catalyst, which is a Lewis acid. Now, aluminum chloride will react with aniline. Aniline, being basic in nature, will react with aluminum chloride, which we are using as a catalyst in Friedel-Crafts reaction. And this is supposed to be a catalyst, and it is Lewis acid in nature. So what happens is aniline will react with aluminum chloride and it forms a salt. Acid plus base, base plus acid will always result in the formation of a salt. So it leads to the formation of salt, that is NH2 plus AlCl3. So because of the formation of salt with aniline and aluminum chloride, you cannot carry out aniline under Friedel-Crafts reaction. So this is the reason for this. Now in the case of the second one, it says although amino group is ortho-para-directing in aromatic electrophilic substitution reactions, aniline or nitrogen gives a substantial amount of meta-nitroaniline. Aniline, when you look at the structure, this NH2 acts as an electron donating group. So as already explained, NH2 acts as activating group which directs the incoming electrophile towards the ortho and the para position. You're supposed to get only ortho and the para product, but what happens is you're also getting a meta product. So what is the reason for that? Now to explain, what happens is you have your aniline. Now when you carry out nitration by treating it with concentrated HNO3 and concentrated H2SO4, sulfuric acid, you are getting a mixture of ortho product, para product and meta product, NO2, plus you are also getting a meta product, that is you have NO2 on the third carbon atom, and you're also getting a para product. Now this one is 57 in percentage. We have done this, and this one is 47 in percentage, and then this one is 2%. Now, what is the reason for formation of this meta product? Because NH2 acts as an activating group. Activating are always ortho-para-directing, but you're also getting a meta product. Now, what is the reason for this? The reason for this is aniline will pick up H plus from the acidic medium and it forms anilinium ion, NH3 plus. Now, this group is deactivating. It is deactivating in nature, therefore it will direct a certain amount of product towards the meta. So therefore you are getting a substantial amount of meta product because of the formation of anilinium ion, which acts as a deactivating group. That's all. So with this, we have come to the conclusion of today's class, and in today's class I have tried to solve questions from all the different portions of amines. I have taken questions from the physical properties, chemical properties, diazonium salts, and the different tests used to distinguish between primary, secondary, and tertiary amines. Surely these questions are not enough. You need to solve more questions which are there in your book. Those shine and taringi zinda nala kari chile laurachina. As a tibo kashi solve chile. Tiba dige takoy physical properties niche, then chemical properties ne. Chemical properties not only basicity gonna tiba kashi chiche, then tests primary amine, secondary amine, tertiary amine, so ever chidan test kashi chiwa dige che. And then preparation of amines gana chiwa kashi chide. And then chiwa kashi chi conversion gana conversion dige the karila shishani chide na replacement of N2 by the different groups. Chemical properties of diazonium salt here. And those chiliads in the ditubahin, and they must say, and the chapter the sawahin, Karinaso, and Jima Zindala, and he looks in Sawachikosugin. So, with this, I'm concluding amines, and in the next class, I'm going to start with the new chapter, and that's all. Thank you.